Welcome to Chapter 1, Catalysts for Change. In this video, we explore the foundations of the information age, as presented in the 4th edition of Ethics for the Information Age by Michael J. Quinn. In this chapter, we will cover 4 key areas: an introduction to the information age, significant milestones in computing, milestones in networking, and various issues related to information technology. The information age is defined by unprecedented access to information. Key catalysts for this era include the development of low-cost computers and high-speed communication networks, which have fueled advances like cell phones, email, the World Wide Web, and portable music players. Technology and values are deeply interconnected. As people adopt new technologies, these tools often reshape society. This influence can be physical, psychological, and systemic, sometimes solving old problems while simultaneously creating entirely new challenges. Society retains some control over technology through adoption choices and development rates. Policy decisions, such as intellectual property laws and tax structures, play a significant role in influencing how quickly and in what direction new technologies evolve. The history of computing is marked by a series of technical milestones, moving from early manual calculating aids and mechanical devices to the invention of the microprocessor and the rise of the personal computer. Long before digital systems, humans relied on tools like tablets, the abacus, and mathematical tables for calculations. However, even with these aids, manual calculation remained a slow, tedious, and error-prone process. During the Gilded Age of the late 19th century, rapid industrialization and corporate growth created a massive market for mechanical calculators. Businesses needed reliable and efficient ways to manage the increasing complexity of their operations. The adoption of calculators transformed the workplace, a process often described as the, quote, de-skilling of bookkeeping. Because calculators made average workers more productive, they changed hiring practices and wages, which contributed to the feminization of the profession. In retail, store owners in the late 1800s struggled with tracking sales and preventing embezzlement. The cash register provided a vital solution by generating itemized receipts, maintaining transaction logs, and providing an audible alert whenever the drawer was opened. Punched cards enabled early data processing systems to sort and calculate data efficiently. Early adopters, including the U.S. Census Bureau and major industries, used these systems to handle massive amounts of input, perform calculations, and produce necessary reports. The move to commercial computing began with experimental machines in the 1940s. Remington Rand made history with the UNIVAC, but IBM eventually dominated the market by building a superior sales organization and investing heavily in research and development. Programming evolved from complex assembly language to higher-level languages. Fortran was designed for scientific applications in 1957, while COBOL, introduced in 1959, became the standard for business applications and government operations. In the early 1960s, time-sharing systems allowed multiple users to access a single computer simultaneously via terminals, lowering costs. Around the same time, BASIC was developed at Dartmouth as a simple, accessible language for teaching programming. Finally, the invention of the transistor, the development of semiconductors, and the integrated circuit revolutionized technology. These advancements made devices smaller, faster, more reliable, and significantly more affordable than the vacuum tube technology they replaced. In the 1960s, IBM dominated the mainframe market, but their computers were largely incompatible. This meant that switching systems required users to rewrite their programs. The IBM System/360, released in 1964, changed this by offering a series of compatible computers, allowing organizations to upgrade their hardware without the need to rewrite their existing software. The invention of the microprocessor at Intel in 1970 was a pivotal moment, putting a computer on a single semiconductor chip. This innovation made personal computers practical. As models like the Altier 8800 and the Apple II grew popular, businesses began to take notice, eventually leading to the launch of the IBM PC. Networking milestones have shaped how we share information. Starting with electromagnetism discoveries in the 1800s, the telegraph enabled the transmission of data via electrical impulses. This was followed by the telephone, the teletype, and eventually, the widespread adoption of radio and television in the 20th century. Modern networking evolved rapidly, from remote computing in the 1940s to ARPANET and email. The 1983 launch of the Internet established a network of networks using TCP/IP. By 2000, broadband brought high-speed, fiber-optic enhanced connections, with countries like South Korea leading the way in connectivity. The 1990s introduced the World Wide Web, which leveraged existing protocols to make information globally accessible. Browsers like Mosaic, Netscape, and Internet Explorer became household names, while the rise of search engines like Google made navigating this vast digital landscape possible. Information technology encompasses devices used to create, store, and manipulate data, sound, and images. As technology costs continue to drop and capabilities rise, IT has become an integral part of our daily lives, influencing how we communicate and work. The rapid adoption of IT has introduced new challenges. While email and the web provide unprecedented access to information, they also bring issues like spam and harmful content. Additionally, digital media and online transactions have raised important questions regarding copyright fairness and personal identity security. IT has also transformed the workplace and global relations. Telecommuting offers flexibility, but can complicate work-life balance and promotions. Meanwhile, global networks allow companies to operate anywhere, and the web serves as both a tool for democratic discourse and a potential mechanism for government surveillance. In conclusion, revolutionary technological change is accelerating. As Seymour Papert suggested, we should move past asking what computers will do to us and focus instead on what we will choose to make of the computer as we shape our future together.